Hello everyone, Haaren is my name. I'm working for Intel as a network software engineer based in Shannon. Today I'm going to talk a little bit about the DPDK telemetry patch set we've been working on. I say we because a couple others in the room here have been working on this with me. I'll get to a slide at the end and credit where credit's due. So we're going to talk about the DPDK telemetry API. I'll briefly introduce what we're actually talking about. So first of all, DPDK and service assurance. So I'm sure some people in the room have already built their own service assurance solution or have tried to deploy an existing one. Perhaps CollectD is involved somewhere to collect some statistics from your platform. So I'll briefly cover that. I'll talk about the solution that we can commonly deploy today. So that's using DPDK and CollectD. There is a solution out there. It's upstreaming CollectD for quite a long time. DPDK enabled this in, I think 16.04 maybe. We just had to add a couple of small functions to enable that at the time. But I'll talk also a little about the issues that involves. And then we'll talk about the kind of the future. So the telemetry library, why is this useful? What does it do? And in particularly, what can you either developers or users of DPDK benefit from this library? Why do you care, basically? So if we talk about DPDK and service assurance, ultimately a lot of the implementations now are ad hoc. There's no standardized DPDK way of doing service assurance. And that results in duplicated efforts in terms of people developing applications, as well as non-standard ways of doing things. So if you deploy a different person's VNF or DPDK application, then you need to monitor it in a different way, which basically means you need to go through the testing and QA of, hey, does this thing actually work? If I take down the application, does it actually get picked up that that application went down? Or if it starts dropping packets, is that being noticed by my service assurance infrastructure? So those are things that we want to minimize, of course. We want one standardized way of doing things that you test once, and then you just benefit from, for every DPDK application that gets deployed, it just works. And you know it works because you've tested it with one, and the implementation is the same throughout DPDK. You just get the benefits of having it in DPDK. So we focus in this case on the primary processes. So if a primary process is being monitored, then you have access to the statistics that's going on. And our target here is to enable this with, for example, just running with a few EAL arguments. So no code changes inside your application are required. Try and keep this as lightweight and as easy to deploy with existing VNFs that exist or existing forwarding applications. So if we talk about what DPDK and CollectD do today, we use the secondary process model. I don't know if everyone's familiar with it, but basically a primary process can forward packets, and we piggyback is the term I use, the secondary process on that primary, and that gives us access to things like NIC statistics and access to the information inside the primary process. And then using the secondary process, we can move the information to CollectD, which then allows CollectD to transmit it or write it to a database or graph it for you on Grafana or whatever visualization tools you have. So in theory, that's a really useful thing that we can monitor a DPDK application over here that's unaware that it's being monitored per se, get the data to CollectD, and then from CollectD it can be consumed into either OpenStack if you're deploying OpenStack or Kubernetes or whatever you happen to use. However, and this is kind of where the pain points of this solution show up, we have the ASLR issues. So if we deploy the secondary process, there's address space layout randomization, kernel security feature. You want to enable that for security reasons. However, that can sometimes cause secondary process to fail to instantiate. So you can't always reliably monitor your primary DPDK process because the secondary might not always reliably come up. So we have the base address or base vert adder hint to try and work around that. So there's a few issues. We need to link CollectD with a specific version of DPDK. So CollectD has a plugin kind of model. The CollectD plugin needs to be linked against a specific version of DPDK. And that means that we have a limitation here that we can't monitor multiple instances of DPDK programs that are running different versions of DPDK because the version between DPDK and the CollectD plugin needs to be the same. So there's complexities here, both in terms of deployment, in terms of reliability with the secondary process, and in terms of packaging and deployment. So I hope with that we've kind of covered, like, OK, this probably isn't an ideal solution in its current state. Other things are we need to poll. So CollectD needs to say, hey, I want some information. It passes that to the secondary process. The secondary process pulls the information out of basically the NIC registers and figures out what's going on and passes that information back to collectee, which then passes it back up the stack. That's a polling mechanism, and it actually needs shared memory between the DPDK secondary and collectee to pass that information around. Again, suboptimal shared memory is generally not a very liked solution for security reasons. It also has a non-trivial threading implementation. If you want to ask about details later, feel free, perhaps over a beer in the pub. Let's see. So look, it does work. I was involved in the design and the implementation, so I'm criticizing my own work here. It does work. It is being deployed, and if it's being deployed reliably, it can be reliable. However, I think there's scope for improvements here, and that's what the DPDK telemetry library is all about. So on that, I've 3 bullet points here to try and, this is simple, to showcase how simple we're trying to make this. So your DPDK application opens a Unix domain socket, or if you want, it just opens a socket. You don't even need to know the details. As a client, so a client in this case being a service assurance client, collectee, for example, takes or rather encodes a JSON string saying, hey, give me all stats, a JSON kind of version of that, sends it to the DPDK instance or the DPDK socket, and then DPDK will reply with a JSON encoded string of the data that's currently active inside the DPDK process. So it's very simple. DPDK opens a socket, you ask it for stats, it gives you stats. And what this does is removes secondary process from the equation. And that's ultimately one of the biggest pieces of value here. We remove a huge amount of complexity, both in terms of linking collectee and DPDK versions, in terms of packaging, in terms of secondary process. All of the downsides I mentioned on the last slide basically get removed because we now use IPC, so inter-process communication, between DPDK and collectee. That allows us to do a lot of things very, very flexibly. And yeah, it ultimately makes it a much simpler solution. So to graphically show you what I pretty much just mentioned there, we have collectee here on the right. There's a Unix socket, which we use for the IPC, and then DPDK with the telemetry library enabled there. Collectee sends a message, so this green arrow, to the Unix, through the Unix socket to DPDK. DPDK reads from, for example, ethdev, pulls the metrics into the metrics library, and then sends a response from the telemetry component back through the socket to your collectee plugin. So at this point, we've ultimately achieved what we wanted. Collectee was requesting some information to pass up the stack or to do its service assurance. It sends a command or a message to DPDK using a Unix socket, very simple stuff. It's just a write system call, right? And there's nothing magical about it. DPDK handles that. There's a control thread running in the telemetry library that picks up, it just blocks on the socket, waits for something to come through. Reads from ethdev the same way anyone would read NIC stats from an ethdev device using the extended stats, so we get a string and a value, passes those back to collectee. We can support multiple different collectee or different service assurance agents, so collectee being one example. As part of the patch set that we've been working on, there's also a Python script, which is a very simple script that just opens a socket, sends this message of, hey, I'd like some statistics. DPDK responds again through the same Unix socket, and we can support multiple clients at the same time. So if you want to run your collectee daemon, and then also as a developer, just quickly poke around a little bit and figure out, hey, what's that particular statistic, and you don't want to open your collectee logs, then a Python script could do this for you. If you want to have your Arduino on your desk show you your packet rate, then a little Python script there would probably solve it for you too. So it's meant to be a kind of a helpful, playful interface to get stats out of DPDK very easily. So to summarize then what this actually gives you, it's a simplification for your service assurance solution. We're getting more reliable deployment because we're removing the secondary process component. We're abstracting whatever the service assurance component is and DPDK by adding a layer of IPC, so essentially inter-process communication. And that gives us the simplicity of we now deal with a socket and a particular message through a socket instead of linking and direct function calls. So that vastly simplifies your deployment, your packaging. So we speak JSON. Pretty much every scripting language or programming language has some kind of JSON binding. So I don't see any reason why your preferred language of choice or infrastructure can't speak with DPDK here. It scales to multiple clients, so that's a nice aspect of it as well. So as part of the work, we developed a patch set for DPDK, which is the actual telemetry library itself. And that's been sent to the mailing list now. We've also developed a collectee plugin as a POC. So this is a telemetry or DPDK telemetry collect-D plugin that speaks the JSON with DPDK to show you how that could work. As states here, the patch set is actually available on the list, so it's 1038 as the ID. Go have a look at it, see what you think of it. The patch set itself has all of the DPDK commits first, and then at the end, there's the collect-D client that obviously needs to be applied to the collect-D code base, but it's included here for compatibility, that it's easy to see that these DPDK commits correspond with this version of the collect-D plugin. So ultimately, that's the work. I'm going to keep it short. I'm going to say thanks, questions. Before I open up the floor to questions, the team who actually worked on this, Brian Archbold, Kira Power, Emma Kenny, were the 3 main developers of this work. Kevin Latz, Lee Daly, and Marco Kovacek were reviewers, helping out with implementation, things like that. So huge props to the team. Many of them are sitting down the back there. Go say hi to them. Fantastic work. I'm really proud of everything that's been done on this. Do have a look at the patch set. Thanks to those who've already reviewed it. There's been some comments and things on the mailing list. And yeah, we're hoping to interact with you guys here and figure out everything. With that, I'll open up for questions. Thanks.
So Keith just presented a Fuse file system to do the same thing. Is there some integration plan here, or was it just a parallel effort?
Very good question, and let me I should have preempted that question, really. So let's split 2 things. One is monitoring a DPDK application that's running. One is configuring and controlling what it does. The other is timeline. So right now, we have a service assurance solution that's working, but can be difficult to deploy. In the 1811 timeframe, we have an LTS release coming up. This is something I think that we can land for 1811, assuming the community is interested and wants to work with this. That would improve our immediate situation, and for the next 2 years, well, we'll be supporting the 1811 LTS. And in future, I actually quite like the DFS system for configuring, so that does both input and output from my point of view. This is very much output-only DPDK emitting stats to people who care about them. So you're right in a way that there is some, I won't say overlap, but similar interests in the DFS exposing some statistics, but the timeline and the use case are quite different. This is much more limited in scope and serves a very particular purpose and improves on our existing solution today, whereas the DFS I see as a more forward-looking future way to configure and orchestrate DPDK. Does that answer your question? Fantastic, thank you. Question there, yes?
I guess you also support not only hardware, so it's not only the eDev you can pull, but you can any software portions also, so any pipes or whatever. But do you plan to add application support too? I mean, the application can reserve a space and...
Very good question. Thank you for asking this. So eDev is currently being pulled into the metrics library, and then all of the metrics library is enabled via the socket, via this red arrow to go back to collect-D. So if you, as an application, actually register metrics in the metrics library, they'll be automatically exposed to collect-D transparently. There is no code changes required in telemetry or any other library for that. So what we need is a bridge, so I'm kind of calling the keep alive component here perhaps, the arrow going to metrics library. That implements adding things to the metrics library. If they're available in the metrics library, then they'll also be available via this IPC mechanism to the service assurance client. So you ultimately get application statistics. If you register them with the metrics library and push them to the metrics library, then you get the rest for free.
Yep. Okay.
Yeah. Very good question, though. Thank you. There's a microphone on your right. Yeah.
So this is just my opinion here. I think how we talk to, let's say, an orchestrator through JSON and Unix socket, I think that's somewhat application code and not really part of DPDK. The telemetry APIs, I think, should come in DPDK, but how do we interact with the outside application should be part of a DPDK application.
Right, so to summarize, you're saying that from a kind of pulling metrics out of DPDK to collect-D, for example, should be part of DPDK, but that how you speak or how collect-D interacts with your orchestrator should not be.
how the collect D interacts with a DPDK application, or how a orchestrator interacts with DPDK application to get these telemetry statistics. I think that should be outside of DPDK.
So
Well, I think.
well, no, go ahead, Bruce.
Does that not end up with a situation where every application does it differently, and then Collect D needs a different plugin for every DPDK application?
Well, I think DPDK is at a layer where it is, providing access to the lowest layer of the hardwares, and I think that's where DPDK should remain, and that will give the flexibility for different applications to do what they want to do.
Right, but again, this is an optional component, and also we're hearing from people using Collect D and otherwise that they want to monitor DPDK applications, just all DPDK applications as much as possible, which is why we're trying to get a solution into DPDK so that you have your Collect D plugin for DPDK apps, and again, it's the 80% of applications you've got with no additional work, and then the guys who want to do a special application-specific method of talking to Collect D or otherwise, they can still implement their own. But my concern would be if we don't put this into that lower level for getting those DPDK stats, every application will decide to do it its own way or will not do it at all. And then you've got no way of getting telemetry out of your DPDK applications. I mean, for instance, okay, the sample apps that we have are pretty trivial applications, but we implement this, you'll be able to get stats out of all of those just for free, just by rebuilding against DPDK. So that's what I would see the advantage of a scheme like this, is we get it available out there and we're able to cover an awful lot of common ground with one shot, so to speak.
Yeah, so to reiterate that, I guess we're saying that you kind of cover the common ground. You say you can have this if you want it. If you enable it, I didn't put the arguments here, but it's -- vdev telemetry, and it'll pop up and start being active. It does everything. There's nothing more. It's about 20 characters or 10 characters on your EAL command line, and it's done. And if you don't want it, don't enable it. It won't get in your way. It changes nothing.
Okay. So today we are supporting JSON, but someone else comes and says that, hey, I want some other format. Are we going to add that format to DPDK?
So I think we kind of miss the point if we talk about the transport between DPDK and something.
That's exactly is my point. I mean, why should we have that transport as part of DPDK?
Because if we don't have it, we lose the capability to talk to anything. And JSON is as good as any as other. So I'm not married to a technology. I just think if we don't have anything, then we lose out the capability of being able to talk to external entities. So we could create our own binary format and say, hey, this is DPDK, you have to speak DPDK to us. But then we exclude almost everything, so why not use something that's common, for example, JSON? I understand there's definitely different points of view, and if you say for your application you prefer to build it in-house and to build a Collect D or a different service assurance component in, absolutely fine. So maybe you're the 20% that we're not targeting. That's kind of what I'm saying.
I think it's not about the 20%. It's about, today it's JSON, right? Someone else comes in and says, I want ABC. Are we going to accept that patch in DPDK?
I say let's wait for that patch to arrive, because I don't see it happening. But I'm not sure. I don't have the answer to that.
I feel that we are kind of bloating up DPDK with these kind of things is what I feel.
Okay. Yeah, sure.
One more comment and we'll wrap it up. Yeah. I think Bruce had a comment.
I'll just give my opinion again, because that's always what I do. I would say if somebody comes and says they want a different format, I think we would have to say no. And we would say, look, this is our default way of doing this in DPDK. If you want to make it talk XML rather than JSON, go implement it in your app. But DPDK provides one default way, which is optional. So we can cover a lot of the market, but we're not ruling out other solutions, but other solutions belong in the application. We're just trying to make it easy, but not mandatory. I think is a key point, and that's how I would see it.
Okay. All right, so on that, thanks very much, guys, and thanks again to everyone who actually wrote the code.